Okay. So actually, let's get started with our project. This is actually our question 2 of assignment, which is working with the dataset that is actually dirty Iris dataset. Which is actually dirty means in a sense that it is actually containing the NA and infinity and none as values, which are actually not considered to be good while considering a dataset. That's actually our question, what it says. Now, what's our question? Let's actually define our question. What we have to do with this data set, this actually will be defined in the question 2.txt. Our question is as follows. Perform the following pre-processing tasks for the data set. So what we have to do is actually make our data set ready for evaluation and getting the patterns from the data sets and insights. Now, our first part is actually as follows. Let's calculate the number and the percentage of observations that are complete. So we have already done it. Firstly, we need to actually load the dataset into RStudio. RStudio is a perfect IDE for working with R and also with datasets because it actually provides us many inbuilt functions which actually available in R and also many functionalities which might not be available when you actually go with command line. So we have to actually make a file and then we have to write all the commands here, and we can also write those same commands in the command which is actually down here. But the thing will be there that you can actually store those commands into a text file like this and then run with the extension .r, and in the case of the command it will be temporary and not permanent and will not be stored in your file storage, so that you won't be able to look up it again. And also the system here is something like this, that you have to actually run line by line, because for example if you want to see the dirty IDs, then you have to select this and you have to press Ctrl plus enter and the command will run. That was actually a command to show the database object that's actually loaded into a database. So how we have actually loaded in the database? By using the reader.csv, which is a function. Reader.csv is not like something like a package and an object or say package or some function. It is actually just a single name which is actually followed as a convention in here dots are also allowed in between the identifiers and function names, and that's actually something so called literals or something. You have to actually you can include dot in between. It means if we are also making some variable, that I think that there must be also dot allowed, because it is not the convention followed in Java or C++. It's a bit different, but yes, it is in many ways same as Python, but the main difference lies in the fact that Python is object oriented while this is actually a procedural programming language. Our first question was to calculate the number of and the percentage of observations that are complete. So we have already loaded our dataset. What are complete observations, which might not include NA or signal values, means which are actually complete, and we have to get the number of those observations. So we have already made a function in this R that's actually equal to say complete cases, and in this we pass the data object that's actually data IDs, which is actually loaded there, and right, and we have applied the sum function here, which actually sums all the true values, because true values are considered as 1 in many programming languages, and false values are considered as 0 in many programming languages, and same in R. So when we actually sum all the ones, then we will get a sum of all the counts of those records in the data set like this, which are actually complete, because you can see this record is not complete because NA is actually available there. And this record is complete because NA is not there, right? It is already filled with each row, and thus we, for the sake of simplicity, we have this. Okay, we have this file saved, and we have this function made, and then we can print the value of this number of complete cases by using this line and then using Control plus Enter, and it will print the things out in the command line as we used to do in Python. We can also use command line, but the procedure is a bit different and also a bit difficult. Now, as printf is a function, it actually prints like the printf function of C language, in which we have to pass the percentage for actually printing an integer, and we in the C we used to actually use %C for printing a character and %S for printing a string. When we have to pass a string variable there must be same similar convention here also in R. Now, there's a function, right? There is a function here that actually is null iris data, means which actually gets the number of records, or say the indexes also of those records which are actually null, and is NA is another function, is NA is there, which actually get the records which are having NA. So what we actually do is actually get those values. So data IDs, braces, and these all values will be actually set to what means what whenever you actually get an empty value, then you will set it to any, right? You can also do something like this, that we are actually first storing it into a variable and then marking those indexes to be actually NA. But we can also do the different way, that we can actually compile it in a single line, something like this, that we can remove this and we can just mark them equal to NA, or we can like this, or we can also say something like a string NA. These both will be considered same, so we will just go ahead with NA. So what we are actually doing is we are converting all the null values, means all the empty values, and standardizing all the NA values to be only NA, nothing like string, and they will be all same, so that we can actually work with them and we can use the drop NA like function. Then we have just viewed our dataset to actually see that all empty values which might be present there have been converted to an A, which is actually not available. A character that actually shows that the particular value is not available for our dataset. So we have done our first question. That was actually getting the number by this sum, and then we have calculated the percentage by using percentage complete cases is equal to number which we have kept in a variable divided by rows. That were actually the total number of rows in our record, which were actually equal to 150. Right, 150 records were there, and we multiply by 100, and this actually was giving us the record, the percentage. So this was our first question. Now going ahead with the second question, I think yes. The second question, according to this text file, is replace all the special values with data in the data with NA, means special values are these two. When these two functions will return the special values, indexes means data from the data IS data set, you have to get the NA, means so if it is actually NA. We also do something like similar convention in Python also, but here it is a convention that we can actually check for the particular values. It will actually iterate over all the values and we'll check if the particular value is a null, means is a empty, then we will just convert that particular value to be NA. Means we don't want spaces there, means we don't want blank spaces there. We want NA either there. And then what we have to do, there was also an infinity, right? Yeah, infinity. So if we don't know, there was also an infinity there. So if we actually don't know the particular function for checking the is infinity, like this is infinity, so we can actually just find that particular value, and that was actually getting at indexes number. The row number was actually 86 and the column number was actually 4, and as R is not zero base, not zero index, so every array, or say every record, or say table, starts with 1 as the first index. So we have got that it was 86th row and 4th column, and we have set its value to be array, right? And then let's look at our third question, that was actually define these rules in a separate text file and read them, right? We have to actually work with rules now, right? That we have to actually work with rules that yes, we have to actually make the rules, and we have to get the record numbers, or say get information about records that might be actually not violating those rules, means might not be actually according to those rules. So what we will do is actually make a new record, right? In this question too, let's go ahead and make a record, right? Make a record, yeah. Like for example, mhm, we can work with those records in a text file, and then yes, here we can actually create a new text file. uh, mm, 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 mm. Okay, no issues. We can actually create from the normal local directory, right? We will go to D, and then we'll go to documents, and we will go to this. right? Question 2, it was our directory, and we can create a normal simple text file. This will be something like this, .txt, and that will be rules set.txt. Let's open it, and we have to define the rule. The first rule says that the species must be in the should be in the from, means these are actually flower species, so they must be from Setosa or Versicolor or say Virginica, means there are three species, and the species must be only from these three species, means whatever the species are actually available here in R, means in this data set, means that species column. Where is that species column? Here is that species column. Is it must be from only three categories. That is actually first is rosa, the second one is actually versicolor, and the third one is actually virginica. Okay, so it must be whole true because we can't see any fourth spaces, but yes, we have to define the rule for it. So let's actually define, and we have to actually use the same column name here. So we will use something like species, species, and we will use percent, and then we have to use c, means from when we actually define a list type data structure, then we use c, and then we have this setosa, and the second one is actually versicolor. Hmm. Let's use the similar convention. Okay, be small, and the third one is actually virginica. There must be also smallest, and the third one is actually virginica. Right. So we have defined the first rule. Let's actually define the second rule. The second rule states that the sepals should be, means the all the measurements should be positive, means everything must be positive. Means what we are actually talking about is actually all the lengths must be positive here, right? So what we can actually say is the sepal dot length is greater than 0, the sepal dot width is greater than 0, and petal dot length is greater than 0, and petal dot width is greater than 0, means something like this is to be defined in the rule sets. So let's define four rules, right? All the measurements should be greater than 0. So let's define it. There are simple rules for this. Sepal dot length is greater than 0, and sepal dot width is greater than 0, and petal dot length is greater than 0, and petal dot width is greater than 0. So all the measurements must be positive. So it will be stated in this way. Then this was actually the second rule. Now let's actually define the third rule, right? How can we define it? Now let's read for what was it. So the third rule actually states that the length of the petal of an iris should be at least two times its width. Something like this. Yeah, that is actually rule that the petal length is actually two times, means at least two times, means it can be greater than two times the petal's width. Something like that rule is actually defined. So how can we actually write it? We can write in a way that yes, petal dot length, means the petal dot length is greater than petal dot width, or maybe greater than equal to, means greater than two times on the petal dot width. So petal dot length is greater than 2 multiplied by petal dot width, right? This will be the rule. That's actually our third rule. Now the fourth rule says that the length of the petal of an iris should be um, okay, let's read out the rule that was in the question. Okay, 30 centimeter means the length cannot exceed 30 centimeter. This was actually the other rule. Mm-hmm. Okay. Means that a length of the sepals should be actually greater than should not exceed the sepal length should not exceed 30 centimeter. Means the rule will be sepal dot length is less than 30 centimeter. Sepal dot length is less than 30. We will write only 30 because there are centimeters already, and we don't need to write unit or something like that because the data is actually stored as a number only, not as a string. So it can actually include those. And there is another rule that actually says that the sepal length, the sepals of the iris are longer than its petals. Means the sepal, we can actually say something like that. Its length, the sepal's length is actually greater than its petals length, right? So what we can write is actually um, sepal dot length is actually greater than petal dot length, right? And this way we can actually save this file, and we have this rules set.txt is our rules in our question 2 folder. So how can we read it? These were actually our records. So these were actually our rules. So how I can actually read these rules. So what firstly I need to actually get those get those rules here in our file. Means how we have to actually read those rules. So firstly we have actually converted everything to our NA. That was actually our question. In our question that we have to actually convert all the special entities with NA. That we have done already. And then we have to define these rules, and we have already defined these. And then the next question arises: how often each rule is broken? Summarize them that we want here. So what we will do is actually read these records first. We need a library called edit rules, right? Library edit rules is required here. So how can we install that library? Firstly, we will actually try to import it if it is already available. Otherwise we can also install that library, and then selecting it, pressing enter. Okay, these are actually, this is actually loaded. Let's actually ignore those errors or alerts. Our library is loaded now. In this edit rules we have the edit.file function, which might be available for these for reading this file. Means whatever the rules that we have defined, we will use edit.file function, and we can store that in our e variable here, edit.file. And in this file we have to pass the location of those stuff, and we are already in the question 2 as our working directory, I think. So we must not be facing any problem in actually loading those rule set. Our rule set file name is actually ruleset.txt, ruleset.txt, right? And pressing them. Okay, could not. Okay, could not find function edit.file because edit.file is not a function here. Okay, just a second. Edit dot, it's already a function. Okay, there is no dot here. Okay, there is no dot in between, but as per as the convention, and that's why I was confused, because the convention is actually followed here, but there is no dot here. So there is no file like this because we might be actually in a different directory for now. That's why maybe it is actually showing this, right? Because we are not in that particular directory, and in this directory we have this rule set.txt, and we can set this directory as our working directory, right? we will go to file and then we will go to more and then set as working directory, so it will change our directory to position 2, and then we will run this particular command again, press enter, and this file will be loaded. If I want to view this, I will press E, then press select and enter, then all the rules will be loaded there. And then now we have to use these rules against our data set. So what we will do is actually we will use violated edits as our function to actually check for a violated rules. So we will say violated edits. This is already a function here without any dot in between, and then firstly the first argument is actually the rule set object, which is actually stored in E, so we'll pass E. And the second one is actually the data object, in which we have the data set stored. So we have the data iris as our object in which everything is actually stored, so we can actually run it. mm, Sepal.word is not found means in our txt file sepal.word is not found. What's the problem in this? Let's actually look at our data set. Okay, sepal dot worth is not found means the W needs to be also capital. We might have actually not kept, not made the W is equal to capital in some way. Yes, here, right? That's why it's showing error and saving it. Okay, there must not be any error, and then running the same commands here. This way means we have to again load that data set because it's actually changed, and then printing it, and then we will run this. Okay, so it has run and it is giving me array like stuff of true and false, where there are number rules means we have 7 number rules and 1 string rule. That's actually work on string objects means which might be actually for this one. There's actually species in this, that's why a column there, column for those, and other 7 1 are actually on numeric values means the value is actually positive or is lesser than 30 centimeter or say greater than some other relative value. So that's actually other 7 rules, and these are actually the record numbers because we have already seen that okay, okay, so it is actually just printing these much of records for now because it is actually not printing all. But yes, this is actually giving us the false and true values means these are the values which it is actually showing, right? So our question is actually not finished, so it is actually showing me that record 1 actually satisfied the num1 means the rule set 1. So it says no, right? Something like that is actually means there are violations or not, something like that is actually defined by these false and true values means if it is actually violated then it might be showing true, and if it is not violated, if it is actually not violated then it is showing false. For the NA values, what we can do is actually we can clean our data set and drop out because it is actually not working on some of the rules because they were NA in our data set. So what we can do is actually clean our data set and then pass this function. We have this much of these things calculated there. So after this we can actually after this conversion to of the special entities to NA, we can actually clean data by using clean data is equal to we can drop all the NA records by using data dot drop NA. This is actually a function. This is actually a Python convention. So in this R we have function drop. Okay, there must be a function. Yeah, we can use help and then drop. Okay, there must be a function drop in it. And if we actually try passing data, where is here? Okay, okay. If we have to remove the columns or the records uh, with the any as one of the entities, then what we will do is just give me a second. Okay, so we can actually get those values which might be not containing NA by using NA.armin, which is actually a function. So drop NA is actually available only in Python, and there is no function like drop NA in R. But there is a convention I am confused. So we can use NA dot omit, which is actually a function which takes in input as a dataset which is actually containing the NA and gives us the values which are not containing NA. So we can actually print those records like clean data, and then using this, and we will see that there is no NA values because every special value was converted to NA already while pre-processing the dataset. And then records have been cleaned up which were containing any as their intermediate record. So this is what clean data does, and we will. Okay, so we can actually also do this earlier. We can do this earlier so that internet is already um, cleaned to any, and then we can run this so that infinity is the record is also removed from here, and then we can actually the rules will be same, there is no change, but we can actually get those record which were violated. This will give us this object, and we can store this, means which we can store all this information in VE. That's actually violated edits, means violated records, and what are the violations, and then we can just show those VE like that. This whole record is being shown this way, right? Now 25 records, 25 records are also present there, and they are just submitted. But what we have, these 25 more means these were acting on 150 values, 150 records. So we have to pass the clean data as argument, which is actually a clean set, right? And then we will actually see the uh, VE because it is a new object, and we have those 148 records now, and you can see that the NA is not present there now because it is actually working on cleaned data set that's actually free of those NA. Otherwise NA was also visible for some records, because whenever we are actually doing some calculation like mathematical ones which actually see that it's this particular value is a positive value or not, then we have to actually we need some numeric value. If there is an NA, then it means nothing and it will not work. So let's see the question 2. This actually find the outliers, means summarize and plot the results, means we have to also plot the results, and this summary is already created with this voided edits, right? We get abstract of those, but we can also get those frequency, that how much those value are being violated. So we have another function that's actually summary VE. Okay, so we can actually just pass, there is an easy function in R which actually is summary, and which takes the validated edits as argument. So when we will just perform this function, means when we will run it, it will get the frequency of those editings, means those violations that's actually that the num2 is actually violated two times, and which is 2.1% of the total violations. And that's actually num3 is violated one time, num5 is violated one, and num6 is violated one time. Means by one record, and num7 is also violated by one record, and there is no violation from that data one rule. Means that's actually let me show you. The data one record is actually about this one. That's actually string, and we have seen that all the records were from all the records from the species column were from words, color, and cetosome, and all three only. So there are no violations. So there is no record into this, and we have also another other information about these violations too around there. Means how much occurrent it is, and how much something like that information is also present there. By there's only a single function. There's actually summary which takes an argument of violated edits. Now we have to also plot the results. So we have another function, another simple function plot here, which also takes a validated edits as its argument. So when we will use this, then it will show us the number of violations and all the editings, right? Like this num7 is actually violated this much, and this is actually the frequency of its violation that was actually present there. Means the numbers and num7 and num5. So our question is actually finished now. Means at till fourth part, and we have to find the outliers also in our record. So we will do it in a second. Now the fifth question actually says that we have to actually find the box plot of this particular data set. Now, what is a box plot? According to this question 5, we have to find the outliers in the separator using a box plot. Means what are the outliers there? Means what are the values which are actually varying too much from the normal flow of those record values. So box plot dot stat is actually a function which actually gets you all those outliers thingy. Means it actually gives you information about the outliers, and box plot actually plots you five things. Now what are those five things? There are things as follows: that you have a minimum value, which is actually a minimum value, not actually the minimum value, but actually the considered minimum value of those record of a particular column. And the maximum value is actually considered maximum value, and then you have three more values. That's actually q1, q2, and q3. q2 is actually the median, means the median value of this particular column of a particular data set, that actually is the medium value, or say the average value of the two mediums in case of the even number of records, when the data set is arranged in ascending order. And similarly you have that q1 value, which is actually the median of the minimum and that q2. And similarly q3 is another point which actually lies in the medium, means in the mid of q2 and that max value. Now, how the max value is actually and min value is actually calculated is as follows: that min value is actually 1.5 times the distance between the q2 and q1, and the no, the mean value is actually 1.5 times IQR. Now, how IQR is actually calculated is actually IQR is the distance between Q1 and Q3. That's actually the distance of IQR, and 1.5 times of it is actually the value of that. Means so when we subtract 1.5 times the IQR from Q1, then we will get the minimum value, which will be actually considered for outlier detection, and 1.5 times the QR when added to Q3 will actually give us the maximum value. So in this way we will actually consider. Now we have plotted this, which is actually getting a graph of getting us a graph of it. And it is not printing other nouns which are actually working on those string values, because it doesn't includes any plotting thingy. Yeah, because it is already 0. Now let's actually have a look at this box plot. So when we use box plot, which is actually a function, in this we'll pass the data iris. Well, okay, we can actually pass the actual data, that's actually data iris, or we can also pass the clean data, which is actually free of the any records. When we we must pass the clean data here instead of those data iris. And then we have to use the dollar symbol, and then we can use anything like sepal dot length for actually plotting the about the length sepal dot length column. and it will give us a box plot something like this, right? So we have to actually use a box plot, and it is on the basis of the data arrays which also contain the previous one. So if you want to remove all these values, means which are actually like infinity ones and other values also, so we need to also we can include that clean data as the object here, because it is free of those NA records, and then we will be free with almost the many of the outliers. And this is actually the center one is actually the mid, which is actually a darker portion, is actually Q2, and this one is actually Q1, and this one is Q3, and this is actually the max value, and this is actually the minimum value in this plot. Now getting the statistics here, we can actually get the statistics here, and by using the box plot dot stats function, right, we can actually get those values. Box plot dot stats function, and in this we can pass the clean data and dollar, and that's episode length again, and then we can actually run it, and it will we're getting a stats, means what are the values which are actually outliers. So these are the values, means the stats function actually give us the actual values. There's the stat actually here a variable which actually gives us those particular value which are conflicting or are in the outlier. So this is actually giving us those particular values, means something like this, or which are out of this range. And hmm, we have another information also here, means means and this n, means this n is actually the number of represents the number of records which are free of the any results, means of non means not available results, means which doesn't contains any value in its record, are actually total of 95 in number. And then we have this confidence value, which is actually this we might leave it for now. And then we have uh, this out variables, which are actually outliers, means number of outliers in our data set for a particular record. So we can actually get the outliers for different one, different column also, right? We can actually get outliers, and what our question says is actually this that okay, sepal dot length, we only need to find the outlier of the sepal dot length, right? Means we have already done it, so we don't need to do it further. Let's save this file. Okay, let's save this file into this question 2. That's actually uh, answer q2 r. We have to actually put the r as extension while saving the R file, which actually includes all those commands, and this is actually done. So we can also put the questions here. That was actually this one is actually for finding the outliers. So you can put a hash and that particular question here for that particular thingy, and then we can get this question, right? Means we have to summarize and plot. So we have used these quality edits, and we can put a hash here, something like that, and saving it. And then what we had also done is actually this rule set, defining a rule set. So this is already here, so we have actually done it. Well, we can put this question down here when we are actually doing it. We can put this, and then reading those rule set can come in question this one is the question third, and the rule set need not to be explained here. Well, we can put this here and a hash. For the sake of simplicity, I must also insert all these rules. Print the component object, means we are printing by this statement. We can put this rule there, hash, hash, using it with a hash. and saving it. And our second part was actually about replace all the special values in data with NA. So that's actually being done here. Special values are being replaced with NA. So we can put a particular question here. Mm, yes, here it is. And then we have the next thingy. This actually calculate the number and percentage. That's actually our first question. So calculate the number and percentage is actually done. And we can do it here, right? Dash, and then it is removed, and then we will print save, and we will press run, and this whole stuff will run. Means control plus C. Let's actually try it on the whole stuff. Okay, so whole stuff is actually done, and we have last record. This was actually a small session about the question 2 half hour. Thanks a lot.